Now it's your turn to expand, multiply, and simplify various polynomial expressions. Some of these involve squared binomials, and others involve different special forms. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In each of these problems, we could rely on the formulas for special products, or we could just go the standard route of foiling. Here, we'll generally use the special formulas. This first one, though, I'll use foiling just to demonstrate what that looks like. So looking at this, we have 4 times the expression x plus 9 squared. And we can see that the parentheses around x plus 9 show that only x plus 9 is squared. 4 is outside of that. So what we have is 4 times x plus 9 times x plus 9. And then multiplying x plus 9 by x plus 9, we'll have 4 times x squared plus 9x plus 9x plus 81. Simplifying what's inside those parentheses, we'll combine the like terms 9x and 9x, so we'll get 4 times x squared plus 18x plus 81. And then our last step here is to distribute that 4 across. So we'll have 4 times x squared plus 4 times 18x plus 4 times 81. And that will simplify to 4x squared plus 72x plus 324. In this next example, we have 3x minus 8, and that quantity is squared. So let's use one of those special formulas here. We'll use the second one, where we have the quantity a minus b squared. And so if we think of this as a minus b, quantity squared, then we're thinking of a as 3x and b as 8. So we'll have quantity 3x squared minus 2 times 3x times 8 plus 8 squared. And when that's simplified, we'll have 3x squared, which is 3x times 3x, which simplifies to 9x squared. And then we're subtracting 2 times 3x times 8, multiplying those coefficients, we'll get 48. So minus 48x, as x is our variable factor there. And then plus 8 squared will turn into plus 64. So when fully simplified, we get 9x squared minus 48x plus 64. Again, we could have turned that into 3x minus 8 times 3x minus 8 and used the standard foiling method. In this next example, we have 7/10 y minus 1/3, and then we're multiplying by the expression 7/10 y plus 1/3. One of the things we want to recognize here is that we are multiplying two things, or two binomials, and one has a sum and one has a difference, but they're otherwise the same. And so that we can use this a minus b times a plus b formula. The advantage here is that our two middle terms are going to cancel, and so if we recognize that ahead of time, we can save ourselves a bit of arithmetic work here. So looking at this one, we can turn this into 7/10 y quantity squared minus 1/3 quantity squared. And again, the reason we're able to do that is that if we were to FOIL this, we'd get 7/10 y times 7/10 y as the first. The outside would be 7/10 y times a positive 1/3, and the inside would be 7/10 y times a negative 1/3, and those are the two that would cancel. Finally, our last would be negative 1/3 times positive 1/3, and that would stay as we've seen here. So we have 7/10 y quantity squared minus 1/3 squared, and now we'll simplify this. When we square 7/10 y, we square 7/10 and we square y, and so we're left with 49/100 as the numerical factor there, and we have y squared as the variable factor. Subtracting here 1/3 squared, so we're subtracting 1/9. In this last example, we have negative 2 times the expression 6x minus 4 times the expression 6x plus 4. There are a number of ways we could approach this. One would be to use foiling on 6x minus 4 times 6x plus 4. Another would be to distribute the negative 2 across that expression 6x minus 4 and then multiply those two binomials. And a third, which is going to be the shortest method, is to multiply 6x minus 4 by 6x plus 4 and then distribute the negative 2 across. Again, we're able to group that multiplication according to the associative property of multiplication. The advantage of multiplying 6x minus 4 by 6x plus 4 first is that it's one of those special products, so we can simplify it pretty quickly. It's actually that third special product where we have two binomials, one which has a sum and the other which has a difference. And so looking at that, we can then turn this into negative 2 times, and we're going to have 6x squared minus 4 squared. Again, the reason we only have two terms is that if we were to FOIL that, the middle two terms would cancel. So simplifying this through, we have negative 2 and then times an expression which has 6x quantity squared minus 4 squared. We'll simplify that expression inside the parentheses, and so we'll have negative 2 times, and when we simplify 6x quantity squared, that's 6x times 6x, so we get 36x squared. Then we're subtracting 4 squared, so we're subtracting 16. So we have negative 2 times the expression 36x squared minus 16. Our last step here will be to distribute that negative 2 across. And when we do that, we'll take negative 2 times 36x squared, and then negative 2 times negative 16. So we're left with negative 72x squared plus 32 when that's distributed.